Hello ENS201 students. Let's see if e-learning is quite efficient and I'm not sure if it can replace the actual sessions in the classroom. However, I believe that technology enhances our understanding of the material. Let's check for the second time ENS201 topic content related to air pollution. So as I mentioned yesterday, the test knowledge, the discussion forum, the material needed are already uploaded on the Blackboard. Please make sure to complete the assignment or the discussion and to complete the test by Monday. Again, this would replace a makeup session and would facilitate the understanding of the material. So today we continue with air pollution. Already we talked about the composition of the air. And now we shift gears to talk about the pollution present in the air. As for the outline, we will talk about types of pollutants and their emission, whether it's natural or human caused. So we do have certain pollutants that we will see that are naturally emitted, others that are emitted by us, by human. And those can be, again, split into primary pollutants, secondary pollutants. We will see what are also the conventional pollutants versus non-conventional pollutants, what is acid deposition. Then we will have a section dedicated for indoor air pollution. Also, we will try to identify 3 major indoor air pollutants, and we will see their effect on human health and their sources of emission. At the end of the chapter, we will talk about current conditions and future prospects on how to limit our exposure and our emission of air pollution. Are you ready? Let's get started. How do we define air pollution? What is air pollution? So, any gas that is spread in a high amount and that can be either corrosive, toxic, that is causing irritation to our respiration, to our eyes, to our skin, this can be a pollutant. So if I ask you whether pathogens, bacteria, viruses present in the atmosphere, whether a fly is considered pollution in the air, yes. So pollutants can be of different types: physical, particulate matter like dust; biological, like pathogens, bacteria, viruses; chemical, like acidity, H2SO4, sulfuric acid, nitrous oxide, high amount of carbon monoxide. So the 3 states of 3 different types of matter: physical, chemical, and biological, can be considered. Now, if you notice here, it says as well noise. So noise can cause disturbance and can be considered as well air pollutant. Others, corrosive gases. Now, there is a threshold of health safety of a certain gas. If the gas reaches levels greater than this threshold, then it is causing an effect on our health, and then we will consider it as an air pollutant. Okay, so example, in China, Pakistan, India, they have a high amount of air pollutants that is present in a 10 times fold higher than the threshold level, and so we will consider these gases as air pollution. Natural sources of air pollution. Let's try to look at the major natural sources. We have here, we can see in the figure, a volcano erupting. So any gases erupting from volcanoes, they are natural sources. Okay, do you identify few? Let's say CO2 can be considered as well if it's at high level a pollutant. Sulfuric acid. Also, we might have sea sprays, so like volcanoes that resemble a spray but in the sea, and they will emit sulfur gases. These are natural. Volatile organic compounds. Volatile, these are, we already mentioned them, certain compounds that can evaporate or spread in the atmosphere quite rapidly. Example, terpenes emitted by plants. Okay, formaldehyde is volatile. Acetone, for instance, if we open a bottle of acetone, it is volatile. So these can have natural sources. Methane, CH4. Do you still remember from where methane is emitted? Example, if we have stagnant water and we have anaerobic respiration of certain microorganisms, then in swamps, okay, we might have methane production. Ruminants, certain animals can produce also bad odors, and these are pollutants. Dust storms, if we have wind and we have dust in the atmosphere, for certain people it is quite irritating, disturbing for the health, and as a result we consider it as an air pollutant. Now, pollutants are split into primary and secondary. Primary, that is, they are directly emitted from the source. Secondary, they are interacting together to form a secondary product. So it's not the primary product that is emitted. Okay, let's have a look at primary pollutants. Here, if we look at the mobile, the vehicle, we have combustion of fuel, and this is releasing carbon monoxide, carbon dioxide, nitrous oxide, dioxide, hydrocarbons. So these are primary pollutants. Now, if they interact under the effect of the sun to form secondary pollutant, example H2SO4, ozone, we said yesterday that ozone is only present in the stratosphere, but if it is present in our primary troposphere, then it is considered as a secondary pollutant. So O3, H2O2, hydrogen peroxide, and other ionized gases that are caused or that are formed by interactions of primary pollutants. Okay. Other emission of primary pollutants, we have stationary or firms, power plants, example here the electrical power plant. We have natural sources, eruption of volcanoes. These are considered primary pollutant sources. Classification of air pollutants, we classify them as conventional or traditional, and based on the US Clean Air Act, we have 7 major conventional pollutants that we will discuss, and we have the unconventional or the non-criteria pollutants set by the Environmental Protection Agency or EPA, and these are toxic or hazardous. We don't encounter them on a daily basis. They are unconventional, however they are present. Example, we will talk about them: asbestos, benzene, formaldehyde, mercury, and PCBs, polychlorinated biphenyls. Okay, don't panic, you will not memorize the names, okay, but just familiarize yourself with the terms, since you might encounter them. Okay, and in the test you will have them as the multiple choice questions, so there's no need to memorize them per se, but to just know them. Okay, the unconventional are mostly anthropogenic. Remember yesterday we said anthropogenic, that is human-made activity. So chemically we produce them, or physically we generate them. Versus conventional, they are naturally emitted from primary resources, Okay, this is the difference between conventional and unconventional. Let's have a look at the 7 conventional pollutants. We have, let's remember, SOx, NOx, COX. S, SOx, E, S, sulfur, O, oxide. NOx, nitrogen, O for oxide. And C, COX, carbon oxide. This can be carbon, mainly monoxide. Then we will have, other than the SOx, NOx, COX, particulates, particulate matter, dust, smoke, hydrocarbons, the ones that we discussed, volatile, perhaps carbons, etc., CH4, methane, lead, lead, and photochemical oxidants. These are the conventional pollutants. Now what we will do, we will go through each of these pollutants, we will see how it is emitted and its effect. So 3 points: the type, the source of emission, and the effect. of each pollutant. Now when we return back, I will distribute a summary table where we have the briefing on each of the pollutant, okay, a summary table. Now at home you can do it as well. For you to practice, you can do a table with 3 columns: type, source of emission, and effect, health effect, and effect on the ecosystem. So the pollutant can have an effect on my health and on the health of the ecosystem. And we will do the same for the non-conventional pollutants. Deal? So let's start with the sulfur oxide. From where is sulfur oxide emitted? We have, remember, S, sulfur, from sea sprays, so volcanoes in the sea. From volcanoes as well, fumes from volcanoes, sea sprays, and erosion of sulfate containing dust from arid soils. So if we have arid soils and it is eroded, then sulfate might be released. These are natural sources. Now human-made sources of SO2 can be by burning fuel, fossil fuel. We can release S, mainly coal. Purification of S containing natural gas. During the processing and the purification of natural gases, we can as well release sulfur. And smelting of sulfide ores. What is a smelting of sulfide ores? Industrial processes. So in mines, when they want to process or purify certain minerals, okay, التنقيب بالمناجم, this will as well release sulfur in the atmosphere. So these are human-made. Naturally, they cannot be released from the stone, from the mountains. In addition, continued, conventional pollutants can be from an interaction between sulfur dioxide in the atmosphere, SO2, and H2O. They will combine together to form H2SO4, which is the sulfuric acid, and then this will be considered a secondary pollutant. Okay, still conventional because it is encountered traditional. It can be present in the atmosphere. We can have a daily exposure to it. Sulfate particles and droplets. So if now we have sulfuric acid in the atmosphere and it rains, the precipitation, we will refer to it as acid rain, and this acid rain contains acidified droplets with sulfur. And this is pollutant because it might reduce visibility. We might have a problem also inhaling in our respiration, so the airway, and this is second to smoking. So first, constriction of airway might be due to smoking. The second reason due to sulfur oxides. Fine. Now let's move to the second conventional pollutant, which is the NOx. So we are done with SOx, now NOx. NOx, naturally, how is it released in the atmosphere? From burning of containing fuel, and from bacteria in the soil or water. Remember, fertilizers that we add for the soil, they contain high amount of nitrogen. So they can be released from the soil, interact with oxygen in the atmosphere to form nitrogen oxide. And other sources of human-caused NOx in the atmosphere include combustion of a fuel from transportation from the vehicles, and electric power generation, so from power plants generating electricity. These are major sources of NOx in the atmosphere. Continued. If now NO2 reacts with H2O, they will form nitric acid. Similarly, it is a component of acid rain. If it rains, then we will have reduces visibility, irritation of the airways, and also it can react with other chemicals, volatile chemicals, VOCs, in the atmosphere, and they will form the photochemical smog. What is photochemical smog? Photo from the sunlight, so it needs the sunlight, chemical reaction between NO2 and VOC, and it will form like a fog. We will refer to it as a smog. Usually if you are coming from, let's say, the Metten highway going down, you can see like there is a fog above the sea. It has like a sand color to orange color. These are smog as a source of pollution. And now if it rains, we will have acid rain, and this will deposit on the agriculture, on the monuments, on our body, and it is a dangerous source of pollution. Okay, reddish brown here. They are referring to it as more reddish than orange brown. The health effects, of course, if we inhale it, it will cause lung irritation, also certain respiratory diseases, and more susceptibility. We will be prone to infections, respiratory diseases, and respiratory infections. Now let's move to the third type, which is the COX, carbon oxide. If you want, you can pause here, do the table, add the SOx, the NOx, and you can add the COX, okay? And then you can show it to me when we come back. And this can be graded as well. So let's do it that way. We can grade it, the summary table, where you have SOx, NOx, COX, natural source, human-made source, and their effect on the health. Okay, ready? Let's go with carbon oxides, COX. How are they released? We can see that the common denominator here is the burning of fossil fuel. They will release all sources of pollutants, NOx, SOx, COX, and also burning of biomass. In this case, biomass here, wood trunk of a tree, grass fires, any fire from a biomass will release COX. Increase of CO2 in the atmosphere is quite dangerous and will affect human activities, will cause global warming. If you still remember, it is considered a greenhouse gas, and so CO2 is a pollutant and at the same time greenhouse gas. Also, a variant of carbon dioxide, if the combustion of let's say a fuel is incomplete, let's assume we are in a room burning a chimney, however we close the windows, we don't have enough O2, so there will be burning of food, however, and incompletely, and this will release, instead of CO2, CO, carbon monoxide. Carbon monoxide is very dangerous. Why? Because it's odorless, colorless, it doesn't have a smell even, so it's the silent killer, and it will stick to the red blood cell, and it will lead to a gradual decrease in O2 circulation in the body, and as a result, suffocation and dizziness and coma, death. So it is fatal if at high levels. Also headaches, dizziness, and even death. Now we move to the fourth type. Also you can pause, add COX in your table. We move to particulate matter. What do you know about particulate matter? It includes dust, smoke, pollen from trees, from flowers, ash due to fires. So these are all irritants. It might really reduce visibility, leave dirty deposit on windows, on plants, on agriculture, on textiles, and as a health effect, it aggravates lung diseases, might cause chronic, not only acute respiratory diseases, and might be a cause for lung cancer. Okay, if you still remember when we talked about environmental toxins, we looked at particulate matter with the smoke. So if we smoke and we are exposed to fibers of asbestos, then we have 10 times fold higher or even more fold higher susceptibility to lung cancer. Okay, so it's a synergistic effect of chemicals interacting together. Then we move to volatile organic compounds, or VOCs, VOCs. They exist as gases in the air. They can be released by plants or bacteria, example methane, isoprenes, terpenes. Man-made sources, they can be either due to unburned or burned hydrocarbons from fossil fuels. So again here, common denominator, fossil fuel burning or combustion, from power plants, from petroleum refineries, also when processing petrol to get oil, coal, etc. If VOCs are oxidized, then they will lead to CO and CO2 emission. They also contribute, as I mentioned in a while, They contribute to photochemical smog by their interaction with NOx. Health effects: they might lead to DNA mutations, reproductive problems, and lung cancer. We move to metals, let's say lead. They can be generated also from fuel products, let's say coal, trace elements, from the release of ore smelting of ore بالمناجم التنقيب عن المعادن. Waste incineration، إذا نحنا incineration burning, we burn our waste, then we might release as well metal. And the effect, let's say if the type of the heavy metal is lead, then it can be neurotoxin and poisonous. So we already discussed this in environmental health. Mercury, also as a heavy metal, if it's present due to burning of coal, power plant, and also waste incinerator, it is highly neurotoxic. Lead and mercury also affect not only the human health but also the health of the certain species and the ecosystem, especially aquatic. We said they bioaccumulate and biomagnify in food chains, aquatic food chains, especially in large fish. So they can pollute lakes. And also we do have different types of metals like uranium, arsenic, cadmium from the batteries, nickel, that can cause pollution and irritation. Here we see as an example of photochemical smog above countries. Usually they are stuck above the cities where we have industries and high sources of pollution emission. Another product of photochemical oxidant that can be present is O3. We said O3, ozone, is present in the stratosphere. However, if it is present in the first layer, which is the troposphere, then it is considered a photochemical oxidant. Ozone would damage our health because it causes a mutation indirectly through UV, لأنه UV is not being blocked by O3. It damages vegetation, building material, and it can be sensitive to our tissue, especially the eyes and the lungs. Okay, other types of compounds, PANs, they are also photochemical, present in photochemical smog. We already discussed it. VOC with NO2 will give us a product for the photochemical, and this is very damaging to our eyes. So this is a summary. We can see primary pollutants emitted from fuel, from vehicle transportation, fuel combustion, from industries, buildings, and these then will, under the effect of solar energy, will cause a photochemical smog as a secondary pollutant. So photochemical smog is a secondary pollutant. Acid deposition, it might contain nitric acid, sulfuric acid, and VOC with the NO2, and these will have an acid deposition or acid rain. I already mentioned the acid rain can affect our health, but also the health of the vegetation and the health of the aquatic species by lowering the pH. It will be less than 5.6, and this will affect the life of the fish, especially the small fish and the egg of the fish. Fine. By this we end the table of conventional and non-conventional air pollutants. Okay, so photochemical smog is non-conventional. Asbestos, formaldehyde, non-conventional. NOx, COx, SOx, these are conventional. Particulate matter, conventional. Please make a summary table, and then we will correct it and discuss it in the classroom once the class is resumed. And this will be graded. Okay, so I will post it as an announcement and linked to this video, but make sure please to summarize the chapter. Now we switch gears to move to indoor air pollution. So in your house, inside, indoor, what do we find as major indoor air pollutants? Definitely cigarette smoke. Luckily, most of the houses banned indoor smoking, and this is quite healthy, definitely healthy. Then we have formaldehyde, asbestos, and radioactive radon. Okay, formaldehyde, asbestos, and radon. These can be indoor air pollutants. Let's have a look at this image. Let's try to see from where do we get, let's say, formaldehyde. If we look at these arrows here, formaldehyde to the right, we can see they can be emitted from furniture, from curtains, especially if we have an old house, old furniture. Let's see tobacco from the cigarette, definitely. Carbon monoxide, asbestos, we will comment on this, we can see it around the pipes. Radon. Okay, let's go through each of the indoor air pollutant. We start with the smoke. We know that smoke is number one indoor air pollutant. The health effect, lung cancer, respiratory and cardiovascular diseases. It's the primary cause of death related to lung cancer. And it's quite costly because economically and financially it causes a big loss of annual loss of illnesses. The second indoor air pollutant, formaldehyde, it is colorless. Sources, common building material, furniture, and certain carpets, they have adhesives on them, on the carpet and the wallpaper. And these, if they are wallpaper, if it's old, they can release certain formaldehyde. Effects, it might cause dizziness, headache, nausea. So nausea, so if we go in a house that is quite old, we feel that we have a headache, it might be due to formaldehyde. This is why you feel that you need to breathe in fresh air. And also it might cause eye irritation and sore throat. Chronic exposure might cause cancer. We move to asbestos. Asbestos is like a fibrous form. It's like fiber. It is used to insulate pipes, to insulate ceilings, as fireproofing, also soundproofing. So if we can see sometimes the ceilings, they are piled with certain thick, let's say like a tile, but thick blocks. These can be also they contain asbestos, and they can be also a source of asbestos release in the indoor environment. Used for insulation and floor, ceiling tiles, and cement. Effects: if asbestos is completely sealed, this means there's no release of asbestos, then it is quite safe. However, if it starts to be released and it's suspended in the air, it can cause lung irritation because of the inhalation, and prolonged exposure might lead to asbestosis, and this will result in death and lung cancer. Okay, developing countries or less developed countries suffer from indoor. However, developing countries, they already have certain measurements in order to limit the exposure to indoor air pollutants. Mainly groups at risk to result in irritation from air inhalation, air pollutant inhalation, are elder people and young children. Okay, now the first sign of lung irritation is bronchitis. Remember, everything that ends with itis is inflammation of the bronchi. The bronchi, the passage pipes that allow the passage of air to the lungs. And these can be inflamed, and they will cause certain cough, muscle spasm around the bronchi, and this will cause us inflammation. Now, severe bronchitis will lead to emphysema, which is a irreversible kind of inflammation of the bronchi, and might as well affect the alveoli at the end of the pipe. Okay, these might be damaged or destroyed, and it is irreversible. Let's have a look here. If we zoom in, look at the circle in the center. It is taken from the major from the trachea, and we can see there are cilia. These are the cells with the cilia. Can you see like hair structures, small hair structures? Okay, and we see the yellow deposit is the mucus. Okay, the fluid that we feel when there is an inflammation. Okay, the yellow fluid. Now if we move downward towards the bronchi and we take a zoom in, if there's an inflammation, this means that the air passage is constricted. There is less passage for air to move in, and this is due to bronchitis. We take medicine, we relax, etc. This can be reversible. So I guess most of us, if we have an infection, respiratory infection, we suffer from bronchitis and then we go back to normal life. However, if it's severe, يعني بيسقط البronchitis to the lower part of the lung, it reaches these tiny sacs which are known as the alveolar sacs, and then we can look, we zoom in, we see the alveoli. These alveoli sacs, like a balloon, they have to inflate and then deflate. Now if they are destroyed, this means we cannot open them and close them back again, then we might have an emphysema, and this is irreversible. So please compare both bronchitis, emphysema, which one is more severe, which one is chronic, irreversible. It's the emphysema. You will be asked about this. Again, elder people, young children are very prone to develop emphysema if they get a respiratory infection. So this is why we are not supposed to smoke in front of a small kid, because then they will have more susceptibility to develop respiratory infections and to have these kind of bronchitis and emphysema, and also elder people. How to reduce indoor air pollution? Definitely we need ventilators. We can see it in restaurants. Indoor, if we have also source of air pollution, we restrict the use of certain sources of formaldehyde, let's say old carpets, old furniture, building material. Make sure asbestos is not released from tilings or insulators, from tiles, ceiling. Okay. Install efficient chimneys, or if you are using inefficient chimneys, all the chimneys, make sure that you have an exhaust of air or a source of fresh air emission. And increase intake of outside air. Even if it's winter, try to have certain breaks to move, to walk around the house, have some fresh air inhalation. Now, as I mentioned, air pollution does not only affect our health, but also the health of plants and forest, vegetation and lakes and aquatic species. For plants and forest, sometimes we can see that certain plants, they have white patches on them. These are because of acid rain. So the acid rain will deposit, will bleach the plant, and the wax around the plant will be damaged, and this causes certain, sometimes even holes. If you look at the plant here, there are even certain corrosive areas. These are holes pinched by the acid rain. Also, they will affect the growth of the plants and the agriculture. Why? Because they will affect photosynthesis and reduces the uptake of nutrients, and as a result leaves will turn yellow, brown, and definitely if we feed on the product of these plants, we will be as well affected by the product that we are inhaling or uptaking. So aquatic life also might be affected because of acid deposition. We already mentioned this. Okay. Effects also on materials. So economically it might be as well costly, because there will be corrosive corrosion of monuments, of buildings. Okay, it weakens buildings, roads, bridges. Sometimes we see bridges that are quite old because of the air pollution might affect the quality of the roads, the bridges. The rubbers might deteriorate and paint might deteriorate because of the buildings. So we can definitely see it in old buildings and monuments. Okay, here this is a description of a monument that is affected by acid rain. We cannot even identify the traces of the traits of the face. Okay, the eyes, the noise, they are being corrosive. Current and future conditions. Definitely non-developed and developed countries are still suffering from pollution. So many measures have been they have to be taken. And developing countries, they have the right filters for their power plants. They have right sources of or the right measurements to track air pollution emission, certain fines and taxes that are put in place where needed, and this is how we can control it. They have banned indoor smoking in restaurants and pubs, and unfortunately in Lebanon, for instance, the policy was not effective, so we still have argile and smoking in pubs and restaurants, and these have to be really seriously taken. Especially it irritates me when I see a small kid sitting on a table with the parents smoking indoor, and the culture has to change. We have to be aware of the health effects of indoor and outdoor air pollution. At the end, what are certain measurements that you do in your place, in your house, and in your country? Be concerned, it's never late. However, we have to raise awareness. Thank you. I will post the test knowledge for this chapter, and I will wait for your summary table for these pollutants. Okay? See you next for the third chapter on ozone depletion. Bye for now.